So technically we just talked about little red dots not so long ago because there was a pretty big discovery. And looks like we have another one coming from a separate team that discovered something else absolutely incredible and something that potentially reveals their nature once and for all. Which means that we have to talk about little red dots once again and discuss this very recent study that just came out in June of 2026. Hello info person, this is Anton. Today we're once again going to be discussing the mystery of these very strange objects and discuss this very strange puzzle discovered by the James Webb back in 2022. A class of objects that we now refer to as little red dots, almost 400 of which have now been officially identified all over the place. And basically representing these tiny, compact, and extremely red sources that we don't really seem to see anywhere else except for extremely early universe, which is where the mystery of course starts. What exactly is this? Why does it look so strange? And why does it not exist anymore? As a matter of fact, for a while, because of their strangeness, some researchers even thought that they might actually break our current understanding of how the universe began. But thanks to this very recent study you can find in the description by Vasily Kokorev and the team you see on the screen, we might finally have the most complete picture yet, because we have some of the most accurate observations of at least one of these objects we're going to be discussing right now. But first, in case you have never seen any previous videos, or in case you're not familiar with these objects, very quick review. So, LRDs, little red dots, what are they? And well, here to understand why this is so important, we obviously have to first understand why these objects appear so unusual. And that's because when James Webb started looking at these deepest parts of space, it surprisingly found an abundance of these red objects that were particularly visible to this infrared telescope. And they all seem to appear at least 600 million years following the Big Bang, but all disappeared within just 1 or 2 billion years afterwards. And it's really their size and their color that makes them so strange. They're relatively small in size, usually less than 100 light years across, and they're also extremely bright and energetic, and all seem to produce this very bizarre red light without any additional observations such as, for example, X-rays or gamma rays. And this created a bit of a headache for astronomers because, well, they kind of looked like baby galaxies, or possibly some active galaxies that maybe grew just a little bit too quickly and became super energized, but in most cases they seem to already be a little bit too large to exist so early in the universe, and they were also not emitting the same type of light as a typical starburst galaxy, or a galaxy that's growing. And one of the first type of an explanation that came out of all of this was actually that these were maybe some of these first stars that existed back in the days when the universe just began, the population 3 stars, which we've never actually seen before anywhere, and so we don't actually know what they should look like, with some scientists suggesting that maybe this is it. Maybe this is what a typical star was like when it was just made out of hydrogen and helium and nothing else. Basically, they would grow into these massive objects, possibly thousands and thousands of solar masses in mass, and become very, very bright, but then also explode pretty quickly. But even here, these observations did not make a lot of sense because, once again, the emissions were just a little bit different, with additional scientists suggesting that maybe this was actually something that was covered in a lot of dust and was basically just a regular galaxy, enshrouded in dust to such an extent that only some light was escaping and everything else was stuck inside. But as of early 2026, neither explanation fit all of the data we've collected over the years. And that's until this recent object referred to as Glimpse 17775, an object that nobody has studied yet, and that now has been analyzed because it actually seems to be in a perfect position to be seen extremely clearly. And that's because if you look at this image, this is once again a gravitational lens, and specifically a lens behind a galactic cluster, a Bell S1063. And so as you can see in this image, this little red dot is actually sort of part of the lens, which in this case allowed researchers to do something that has never really been done before: the deepest spectrum analysis from any little red dot to date. Or just to rephrase this, researchers were able to physically see what sort of elements seem to be contained inside this object by looking at specific emission lines coming from the light that's over 13 billion years old. And so in this case, James Webb spent approximately 30 hours looking at this, but because this is a gravitational lens, the data in this case appears as if we looked at it for at least 80 hours. which was enough to produce a very accurate spectrum, which is precisely what this entire paper is all about. And so here, when the team looked at the light coming from Glimpse 17775, they actually discovered over 40 individual spectral lines acting as chemical fingerprints. And well, to everyone's surprise, this was extremely different from a typical galaxy, from a typical star, and even from a typical black hole. So this actually was exotic, but it still was something that we know of. Because in this case, all of the data supports a relatively recent model referred to as a black hole star scenario. And we actually have a picture representing this as well. And that's because in this particular model, this object is not just one giant star, and it's not just one giant black hole, but instead it's sort of kind of something in between. Or to be more exact, this is a supermassive black hole that's actually growing extremely fast, but is completely enveloped by a dense cocoon of gas. And in this case, this cocoon is so ridiculously thick, and the black hole is so ridiculously powerful, that all of the energy coming from the black hole then basically starts to make this cocoon reprocess the light, which then makes it glow, making it resemble a gigantic star. And so it's a black hole powered star, with all of this light essentially being the result of the black hole activity, but being created by the gas around this object. And in this case, the evidence is actually quite intriguing. As a matter of fact, we have 5 specific pieces of evidence, or independent clues pointing at the same conclusion. First, the idea referred to as Thomson scattering. And that's because the light from the gas does not look like it's just rotating, and instead shows signs of scattering, where light bounces off electrons in a very dense, layered gas shell. We sometimes see something very similar during certain types of supernova, or in locations with a lot of thick gas. There's also something referred to as the iron forest, and that's because in this case the spectrum revealed 16 different lines of iron, which is why it's called iron forest, which is produced when the iron atoms start to glow because of ridiculous amounts of energy. And in order to produce 16 of them, or basically in order to make iron glow 16 different ways, you need to have a high energy engine, like some kind of a rapidly fading black hole, because nothing else is powerful enough to produce any of this. Then we also have some helium and oxygen clues, with detected helium and oxygen behaving in ways that only happen in extremely dense environments with intense radiation. Then, importantly, we have what's known as the Balmer break. This is a very specific dip in the wavelength of light, around a wavelength of 364 nanometers. And it's actually caused by behavior of hydrogen atoms, and is most pronounced when a galaxy is populated by extremely hot and extremely powerful A-type stars. But in this particular case, the Balmer break is actually pretty weak, and is technically even weaker than other little red dots, which seems to be the result of the host galaxy surrounding this object. Or to be more exact, in other little red dots, host galaxy is not something that has been usually seen, but in this case seems to be visible just a little bit. In other words, this object seems to also contain a galaxy around it, but we just don't really see it because it's super far away. And lastly, we have certain absorption features, such as gas actually blocking some of the light, which usually happens when the gas is under very high pressure and extremely close to a central black hole. With all of these features essentially telling us that this is indeed an extremely compact, super dense, and super hot object that was basically proposed to be something like this. And this right now is super important for solving major issues that could not be addressed previously when these objects were just discovered. In other words, it solves that broken cosmology problem. And that's because now we don't have to assume that these are impossible galaxies that somehow grew too fast, or that these are population 3 stars we've never seen before, or maybe that these are some really bizarre black holes, gigantic in size, that start glowing with some bizarre colors. Instead, what we are seeing are basically young black holes that are growing ridiculously fast at what's known as super Eddington rates, and start to emit so much light that they basically cause the gas around them to start producing this super intense glow. But because they're also consuming gas much faster than a typical black hole, they also end up forming these very massive shells in their own surroundings that then do not allow any light to escape and produce these powerful emissions. Which also kind of explains why these objects are usually extremely faint in X-rays, because this was actually one of the main reasons at first scientists did not think these were black holes. Normally, central black holes produce a lot of X-ray emissions, but here almost nothing was visible. As a matter of fact, almost none of the little red dots produce any X-rays, with only some of them producing just a little bit. We actually recently discussed at least one such object you can learn about in a description. It's technically now known as the X-ray dot. And so here the explanation is that this is all the result of super dense gas, actually denser and thicker than anything we see in the local universe, and basically gas so thick that it literally creates star-like conditions around this black hole, with the gas then behaving in the same way it usually behaves around stars. Although in this case it just starts to absorb a lot of this high energy and then re-emit it in a very specific wavelength. But along with that previously mentioned X-ray dot and a few other additional discoveries, including the discovery of a naked black hole, once again the video should be in the description, scientists are now almost certain that these objects are black holes, but just surrounded by some very extreme environments, with this specific object, Glimpse 1775, very likely containing a black hole that's about 4.5 million solar masses, or essentially extremely similar to what we have in the center of the Milky Way. And though this might sound huge, it's actually approximately 10 times smaller than what scientists initially guessed when they did not account for all of this gas resulting from the cocoon surrounding the black hole. In other words, there is a lot of this gas around the black hole, and it basically makes it appear to be way more massive than it really is. But in the end, this is now the best evidence we have for the existence of these black hole stars. And not just one or two, the early universe was potentially crowded with these objects because they seem to represent some kind of a very typical energetic phase of a developing black hole, where the central black hole starts to grow ridiculously fast and seems to be surrounded by these massive thick shells of gas for at least some time. And the evidence from this particular study suggests that many, if not all, little red dots are actually these gas-enshrouded black hole stars. And I guess once again importantly, the data here fits with all of the previous observations, and most importantly, with all of the previous predictions from the modern cosmology. As the main scientists put it, everything fits, nothing is broken. It just, we're now finally understanding how the early universe was just a little bit more extreme and a little bit different. On that note, we'll probably come back and discuss this more once there are some additional discoveries, but until then, check out previous videos on little red dots in the description below. Thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.